Okay, question 12 is an exponential question. We've got this exponential function here, and the first part of the question wants us to work out what p is equal to. We know that t is the number of years after January 2001. So January 2004 will be when, 5 will be when t equals 4. So when t equals 4, we know that the value is 32,000. We also know that in 2012, so when t is 11, the value is 50,000. So if we substitute those values in, we'll get a pair of simultaneous equations. So we can say that 32,000 is equal to a times p to the 4. And we can also say that 50,000, is equal to a times p to the 11. Now, there's a few different ways you can solve this. You're probably going to make a the subject of one of them, and dividing by p to the 4, say, and then substituting that into the other equation. So 50,000 is equal to 32,000 over p to the 4 times p to the 11. P to the 11 divided by p to the 4 is going to be p to the 7. So 50,000 is equal to p to the 50,000 over 32,000 is equal to p to the 7. So p will be the 7th root of that value. So the 7th root of 25 over 16. To 4 decimal places it wanted. That's 1.0658. Okay, part 2 of this says to show that A is approximately 24,800. In order to do that, we had to, actually, the mark scheme was really mean. We had to substitute it in for both of these two situations and show that for both times they rounded to 24,800. It wasn't obvious from the marks from the question that you needed to do that, because it just appears that this has been rounded to 3 significant figures. But the mark scheme wanted us to show that A was equal to one number when we sub it into the t equals 4 equation, another number when we sub it into the t equals 11 equation, and based on those two values, the best we can say is that A is equal to this number here. So let me show you what I mean. This is for part, is it B? Did they call it B or 2? Part 2. We've got that A is equal to 32,000 over 1.0658 to the power of 4, and we also have that A is equal to 50,000 over 1.068 to the power of 11. So if we work out both of those numbers, the first one gives us 24,796.8, and the second one gives us 24796.8. Both of those numbers round to 24800. Part 1, it wants us to interpret the value of A. A is the initial value of the car when t equals 0. So if we substituted t equals 0 into the equation, we'd get p to the power of 0, which is 1, times by this A value that we've worked out will give us the value of the car. So the value of the car on January the 1st, 2001 is what A represents. So the initial value, I would say. Which is obviously in 2001. P represents the amount, the factor or the percentage that the car increases by year on year. So it's the multiplier, if you like, the factor. Don't use the word amount because that's like you're adding something on. If you use something to suggest that it's being multiplied, that they prefer that. So the factor by which the car or the value increases each year. And part C wants us to use the model that we've worked out. So we've got the value is 24,800 times by 1.0, what was it, 1.0658 to the power of t. When is the value first over 100,000? So when does this become greater than 100,000? I'm going to divide by 24,800. Which gives me 4.032. Then I'm going to log both sides. I'm going to natural log both sides. Doesn't matter which log you used. You could have used the log of the base 1.0658, I suppose. Bring the t to the front. And divide by the natural log of 1.0658. Okay. That's giving me 21.88. So that means at some point during the 21st year, and towards the end of the 21st year, the car exceeds £100,000. So if we add that on to when this first started, 21 years plus that 2001 is going to be somewhere in 2022. It will be right near the end of 2022, but it will be during the year 2022.